Hello everyone, my name is Francis Reyes and welcome to my presentation. Today I will be talking about implementing a school-wide curriculum change at Franklin High School located in Somerset, New Jersey, which involves including the subject of art into STEM classes and vice versa. My agenda will be to first introduce about the importance of STEM fields in the United States. Then I will dive into more detail about the problem that students face at Franklin High School and the solution to introduce a STEAM-based curriculum. I will also talk about successful efforts of integrating STEAM in other schools and libraries in the past and how we can model this plan into Franklin High School. A proper education in STEM is crucial to the American education system, especially in the current 21st century. STEM careers are the fastest growing, most important, and most versatile careers in the United States. They account for 80% of the total fastest growing careers. Workers in STEM are at the forefront of the nation's growth in an increasingly technology dependent society because they directly drive innovation, the economy, and business. Between 2012 and 2022, employment in STEM-related occupations is projected to grow more than 9 million. This means that the U.S. as a whole needs to find ways to improve the education system for STEM learning. Today, we will focus on a specific high school of which I attended from 2010 to 2014. In September of 2016, Franklin High School was ranked 181 out of 337 total high schools in New Jersey, according to the list published by the magazine New Jersey Monthly. This ranking is based on most recent school performance reports from the New Jersey Department of Education, as well as factors that weigh in student participation in advanced placement courses and in visual and performing arts classes. From the data, only 19% met or exceeded math expectations. That means that 81%, or the majority of the entire school, did not meet those expectations. Similarly, 86% did not meet Algebra 1 PARCC expectations, 80% did not meet Geometry PARCC, and 78% did not meet Algebra 2 PARCC. The PARCC stands for Partnership for Assessment of Readiness for College and Careers. About half the students who took the New Jersey biology test did not meet expectations. Clearly, there is a huge need for improvement. Let's take a look at the electives offered at FHS. Electives are classes that students can opt to take outside of their core curriculum. There are only 14 electives in STEM, which is not a lot to choose from for the students who are interested in math, science, or technology. However, there are 54 electives in visual and performing arts, and these encompass music, drama, TV production, and art. As you can see, due to the fact that there is a high number of visual and performing arts electives offered, a total of 87.1% participate in art classes. Don't get me wrong, this high rate of participation is not a problem at all. I think it's a great thing that students have the outlet to express their creativity. However, I think it would be more effective to incorporate STEM into current art classes and vice versa. This is where STEAM comes into play. STEAM is a movement to interrelate the arts with STEM, or science, technology, engineering, art, and mathematics. This is a new paradigm shift in the American education system. It is proven for STEM to naturally involve art. For example, take a look at Apple and the iPhone. It is a piece of aesthetically pleasing technology that fits into the palm of your hands. Notice that Apple products have completely no screws or noticeable seams in them. This could not be made without the knowledge of both STEM and art. So why incorporate the arts into STEM at a high school? For one, this will help showcase that technical fields require knowledge of artistic principles, like the iPhone example. This will also help to enhance scientific literacy, which, according to the statistics from the New Jersey Department of Education, which FHS clearly needs. This will, in turn, improve overall academic and testing performance. The following are past successful STEAM efforts. An example of a successful shift from STEM to STEAM is in the DeSoto Independent School District in Texas. There are 3 iSTEAM academies working together to incorporate art principles in STEM. For example, students are assigned a project to create a model of a city. The students must use 3D printers to create roads and buildings, while using art to design bridges and other objects in their cities. The schools confirm that STEAM approaches are improving the quality of learning, with students outperforming the traditional textbook classroom setting. Research was also conducted in South Korea to observe the effect of STEAM education in elementary schools and how it impacts improvement in creative thinking. One study focused on using a shape creator program to teach the students the basics of information technology or IT and how certain commands will draw the shapes that they want. The second study analyzed the effect of Ruby Goldberg machines to improve kinesthetic and collaborative learning. Students work together to design the most complex machine to perform the simplest task, using their imagination combined with STEM concepts to build a machine. Another unique effort to improve multidisciplinary learning would be to incorporate a makerspace at the school. A makerspace is a hands-on area that provides tools and equipment like 3D printers, robotics kits, and crafting supplies. This allows individuals to express their creativity in a more technical outlet. For example, the L.E. Phillips Library in Wisconsin recently opened their own makerspace called the Dabble Box for patrons to enjoy a more immersive, hands-on library experience. There has been lots of positive feedback, especially from many families. They look forward to coming back to attending the weekly workshops and events and spreading the word about the success of the local makerspace. Here is my plan of action regarding preparation. First, we need to acquire materials, machines, and equipment to set up the makerspace. Then we need to inform both STEM and art instructors at FHS the new STEAM initiative and help them to create joint lesson plans that are revised from last year. We also need to train teachers to use the equipment that we're going to acquire and collaborate for joint student assignments in the makerspace. We also need to have students take a survey about interest in STEM at the beginning of the year before immersion in new STEAM courses. Regarding execution, students need to work on projects for different electives and classes using the makerspace and STEAM curriculum principles. Students with more strengths in art can work on the design portion of an assignment, and students who possess more technical and STEM-based skills can work on the technical aspect of the assignment. This will allow them to work together and teach each other the different principles of each field. An example of assignment that they can work on is 3D printing. They can work together to design a product on SolidWorks, which is a 3D modeling and drafting software. One student can learn how to design the model with dimensions on SolidWorks, and the other can learn how to physically print the project using the 3D printer with the materials acquired in the last preparation. Regarding the last step of the plan of action, which is follow-up, students will participate in an end-of-year survey about their satisfaction and interest in STEM fields after immersion in STEAM during the first year. Teachers can provide feedback for improvement for following years. If the initial plan is successful, we can continue to add more STEAM lesson plans into current and new classes. If it is not successful, we can provide new ways to improve from last year. Here is a summary of my rough budget for the year. First, we need a classroom to house the makerspace and the materials that we plan to buy. We also need training for the teachers so that they are aware of the equipment and how to use the equipment to teach their students. A 3D printer would cost around $1,000. The SolidWorks CAD license and software is about $4,000 depending on how many computers you plan to install this program. Printing materials for a 3D printer costs about $30, which is the plastic used to print on the 3D printer itself. Safety equipment and tools will cost around $300. Instructional materials will cost about $50, and robotics kits will cost around $400. To wrap this up, there is clearly a need to improve overall academic and testing performance in Franklin High School, and I truly believe that integrating STEAM will allow for higher student motivation and interest in STEM fields. My own current involvement as a community outreach chair for Rutgers University Makerspace Club has definitely added to my knowledge of how exciting a creative yet technical workspace can be. Please let me know if you have any comments or questions. I'd be happy to answer them. Thank you for attending my presentation.